Hello, welcome to my channel. We have been solving these past papers. Right now, I have this mathematics, probability and statistics, and it's May, June 2024. So let's start the question. I will do this question number one today. Okay, a bus station has exactly four entrances. In the morning, the number of present passengers arriving at these centers are okay. Basically, this is a problem of Poisson distribution. What is Poisson distribution? It's a discrete distribution. It says that if in a certain time interval, right? If this is the time interval, in this time interval, how many times something can happen? For example, in this particular question, that how many passengers can come in this interval, right? Okay, so this bus terminal, it has four entrances. So let's say one, two, 3, and the 4. So out of four entrances, uh, the probability of coming people, it is Poisson distributed with parameter zero point 0.4. I will tell you about what is this parameter. One is parameter 0.1, one has this Poisson parameter zero point 0.2, and one has this Poisson parameter zero point 0.5. Right? Okay. What's the meaning of this thing? For example, it says that the number of passengers coming in this 10-second interval, right? This is for the 10-second interval. So if this interval is 10 second, then people coming in this interval, it has a Poisson distribution with this parameter. What does it mean? That probability that passengers x is equal to a, right? This is equal to e to the power minus lambda, and that lambda is zero point 0.4. Okay, so let me write zero point 0.4 here, and zero point 0.4 power a over a factorial. Okay, so knowing the value of a, for example, if I want to calculate what's the probability that five people come in this interval, so a is equal to 5. I will put 5 here and it will give me the probability. So this zero point 0.4 is the average or the mean number of people in this interval. Okay, so let's come to this thing. So if I assume that this bus terminal has only one entrance, right? And the number of people coming in each 10-second interval, that's going to be all of this thing, right? So zero point 0.5 plus zero point 0.2 plus zero point 0.1 plus zero point 0.4. So this is going to be a Poisson distribution with 1.2, right? Okay, now this 1.2 is for 10-second interval. So what about 1 minute? Because I want to calculate in 1 minute, right? So for 1 minute period, the same thing, okay, one entrance, and it will be Poisson distributed with 1.2 times 6, right? So this is 7.2. Okay, so our problem is a Poisson distribution with parameter 7.2. So, and this parameter is called lambda. Okay, so for our problem, lambda is equal to 7.2. I was about to write 0 point anyway. Yeah, it is 7.2. So remember this thing. Okay, now we have to calculate what's the probability that in 1 minute period there are more than three passengers will arrive, right? Okay, so how will I calculate this thing? You see, number of the probability that number of passengers is equal to zero. Okay. Number of passengers equal to A is equal to what? It is e to the power minus lambda, which is minus 7.2, and 7.2 power A over A factorial. So this will give me the probability that number of A passenger will come in this 1 minute interval from all these combined four entrances. Okay, so what's the probability that no passenger will show up? Right? So it is e to the power minus 7.2, and 7.2 power 0 is 1 and 0 factorial is 1. So this is the thing. What's the probability that only one passenger will arrive? So this is e to the power minus 7.2 and 7.2 power 1 over 1 factorial. Okay, what's the probability that two passengers will arrive? This is e to the power minus 7.2, 7.2 power 2 over 2 factorial. And what's the probability that three passengers will arrive? That is going to be e to the power minus 7.2, 7.2 power 3 over 3 factorial, right? Now, what's the probability that number of passengers x, it is more than 3, right? So it is 1 minus probability that no passenger will come, or one passenger will come, or two passengers will come, or three passengers will come, right? So if I subtract it from 1, it will get, I will get the probability that more than three passengers will come. Okay, so this is equal to 1 minus, and then probability of 0 is e to the power minus 7.2, plus next one is e to the power minus 7.2 times 7.2. Next is e to the power minus 7.2 and 7.2 square by 2 factorial, which is 2 only, plus e to the power minus 7.2 into 7.2 power 3 over 3 factorial. Okay, I have this all clear. So we just need to calculate this expression, and that would be 1 minus, I can take e to the power minus 7.2 common outside, 1 plus 7.2 plus 7.2 squared by 2 plus 7.2 power 3 by 3 factorial. So this all comes out to be 1 minus e to the power minus 7.2. 1 plus 7.2 plus, oh, what did I do? There is no bracket here. 7.2 square over 2 is 25.92, and 7.2 power 3 is 62.208. And when we calculated all these things, it comes out to be 0.928. Three significant digit. So this is the probability that more than three people will arrive in 1 minute interval. I hope you understand everything here. You need to understand the logic behind everything, right? If you can form the logic and you can understand the reasoning, then you can solve the problem. Thank you very much for watching. If you like my videos, please subscribe them. And if you ever have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.